Hi everyone, and thanks Özgür for letting me having this presentation. It's my first time here in Cloudbear Stockholm. I've been attending Cloudbear in Karlskrona and Gothenburg before, but first time here at Gut, and it's good this far. Good first presentation of Ola as well. So, getting started with OpenStack. That's the subject. My name is Tobias Rydberg. I'm working at City Network as a developer. My main focus at City Network is building our cloud management system, or as you may know it, the interface that you interact with our services, if you have ever used it. I also do some other stuff as well, like operating our 11 OpenStack based cloud nodes that we have around the world. Lately I've also got the opportunity to work a little bit inside the OpenStack community as co-chair of the public cloud working group. So that's me. And I like beer as well. OpenStack. How many of you here knows what OpenStack is? The most of you, so I can skip this part then. Just a few words of OpenStack. It's like a software toolkit for cloud services, or you can call it an operating system for a cloud, so to say. It's completely open source, and it's written in Python. And today I think it is a bit over 20 million lines of code. And it's the fastest growing open source project in the world right now, if I have heard it correct. More than 40,000 people that are active in the community. So it's pretty big. It was born in, I think it's 2010, and initially created by NASA and Rackspace. And later handed over to the community of OpenStack to continue development I think that was in 2012. So now the community is developing OpenStack, and it's a complete open design process. So 2 times a year the community gathers and decide and prioritize what's to focus on for the upcoming release. Yeah, and the world runs on OpenStack. That's pretty cool, actually. Hundreds of the biggest companies in the world relies on OpenStack today. Since you know what OpenStack is, you probably also know that it's based on individual components that come together to do this cloud service for you. And every component or project, as it's called in OpenStack, has its own features, like Neutron doing the networking and Nova doing the computing. And today I think it is around 60 active projects in something that OpenStack calls the Big Tent. And to become an active project, if you have an idea of something that you would like to see, this feature is missing in OpenStack, you're free to start to implement that and create your project according to the guidelines of OpenStack, so to say. And then you hopefully get a project inside the Big Tent. So how many of you are operators here, or doing some kind of operations, or running your own OpenStack cloud? A few. Have you deployed all the 60 projects? No, you haven't. No. We haven't either. So that's a good thing. You don't have to deploy them all. You just take the ones that you feel suitable for your use case and bring them together, and you're good to go. And some of them, as you see, are named as core services. And okay. OpenStack is completely API based. This has full API support, so everything that you can do with the cloud you can do through the APIs. Some years ago the APIs were not that well documented, but I believe they are today very well documented. It's very easy to follow and to get the information you need to be able to do the requests you want to do. And the APIs are, of course, it's key for automation, it's key for interoperability, and some of those things we will see later on as well. So how many developers do we have here? Great, it's me. Okay, so talking about knowing the audience before you're doing your presentation. This presentation is about getting started with OpenStack, so I'm going to show you 5 different cases of how to interact with an OpenStack cloud, consuming services of a cloud. So I just move on to the do you see anything at all? Yeah, somewhat. It's green stuff. Okay, good. First of all, I was going to show you an example of just authenticating to the cloud using the web APIs or the REST APIs that you can use from any language, any application, whatever application you are running in your organization. So authenticating to an OpenStack cloud is that you request a token, in this case, using the APIs, that you then use to communicate to the other services, for example, spinning up a new VM and stuff like that. So we will get a token, and you do that through Keystone, which is the identity manager of OpenStack. And here we also get a list of the available services that is provided by the cloud you are authenticating to or against. So here we can see that we have Nova, we have Neutron and stuff like that, and the URLs to the endpoints of those components. So we will spin up a VM as well, which we do using the Neutron Nova APIs, but we also need some stuff to do that. We need to know which flavor or which image to base it on, and which network to put the server on to get the connectivity. And that's pretty simple. I think it's pretty straightforward, and if you are used to working with any REST API, it's very straightforward. And hopefully we will get a server here as well. Since it's pre-recording, I think we will. So nobody in here is doing any kind of API stuff or development stuff? A little bit. Okay, a little bit. Just for fun.
Compared to you, no. I can use Postman, that works.
Good. Yeah, okay. We see that we got a server here. Another way of interacting with an OpenStack cloud is using that I used to call the project or the project clients. Each individual project or service of OpenStack has its own command line client. For example, Neutron client, Nova client, and stuff like that, where you can do everything you can do against Neutron. You do that via the Neutron client. And to be able to interact with the cloud via the client, you have to provide some credentials. And this is basically how you, in the normal use case, do it. You create a file, put in your credential, and source that file so you get those variables into your environment. And by doing that, you have them. You talk directly to Nova that authenticates for you to Keystone and give you the resources that you are requesting. So to say, in this use case, we are going to assign or create a new floating IP and assign that to the VM that we just created in the other example. And to be able to assign the floating IP to the server, you need to know some stuff. You need to create the floating IP on a specific network, so you get a floating IP that is externally accessible, and you need to know which port on the network the server has. So you need to know the port ID, and you need to know the ID of the floating IP. So I think we see the port here, and we also see that it looks like the device owner is compute, so probably that's my server right there. So this is basically how the ops guys are working with it. Developers maybe more with the APIs in their applications, and the operation guys using these kind of the project clients, and they are very powerful. And I think this is the most common way of operating your cloud, or the resources of the cloud you are using. Okay, so it's a few commands you have to put into to get it going, but I think we're soon there. So yeah, there we're done. Moving on to the next one, and that is the OpenStack client. That is a project that I don't know how new it is, but it's also a command line client, but it has combined all the other clients, so to say. You have access to the Nova APIs, the Nova client basically, and the Neutron APIs in one client. So it's very one of the things they were thinking about when they designed this and built this, it was simplicity. You don't have a unified language in the other clients. For example, if you do a create, you do floating IP create, but if you're using the Nova client, you don't do create, you do boot, or you do assign, or you do add. It's not unified at all. So they unify the language as well. So you do, for example, you do server create, you do floating IP create, so it's more logical to use. And another part of that the OpenStack client is using is something called OS client config, or cloud.yaml as it's called as well, which is very good for interoperability. Because you have a file in your environment where you specify the credentials for all your clouds you have. I have my Cloudbear cloud here, which is a city cloud, but you can have your private clouds. You can have whatever cloud you want in here, the clouds that you are using and consuming resources from. So let's see an example of that. Oh. So here we will see that we specify which cloud we will interact with when at command line, and you will probably see we're doing the same use case here as we did in the other example, and I think the OpenStack client is much more. Yeah, it is easier to use, and it's doing shortcuts for you as well. So you don't have to know the port ID on the network for the specific server. You only have to know the floating IP address and the server name or server ID to be able to assign a new floating IP to it. You getting this, Jens?
Not at all.
Because I'm going to force you to do this later on, since you should know everything about this now.
Focusing on the beer.
Okay, good for you. Okay, so we have the IP and we have the server as well. So we just add that floating IP to the server.
But that requires that you have a actually network interface for that server that is in the same network as your.
Yes, in this case.
Right? You cannot how you can decide which interface getting this?
In this case, I don't specify the interface. That's right. But if you don't are advanced user of OpenStack, you probably just want to get an IP on your server. So you have one network and you want to get access to it, so to say. But if you are a more advanced user, of course, you have the more advanced options in the specific project client, so to say, where you specify a port or other advanced stuff, so to say. Okay, we got connection as well. Good. Since we are very many developers here, everyone has used Shade or are doing a lot of Python coding. But if you are, Shade is a very good tool. It's you can call it the OpenStack Client library for Python, so to say. It's a library working almost the same as the OpenStack Client. It's simple, very simple, and using the clouds.yaml feature as well. So you specify the cloud you would like to interact with. And yeah, so do a code example of that as well. In this example, we will create a server, and we still need some information. We need an image, we need a network, and we need a flavor. And then we put something called auto IP. So we would like to have a floating IP assigned to this server automatically. So Shade does all for you. So if you compare this to the first PHP example I showed you, this is much more simple.
So
Is it using the heat in the bottom?
No. But it can. You can do heat commands as well. Okay. We see that we got the Shade server and has assigned an IP automatically here as well.
So Shade is your orchestrator?
No, Shade is not the orchestrator. Shade is a library for Python, so to say. So you get, yeah, it's a client library for Python. And it's very simple to use. It does all the authentication and everything for you. You don't have to do that yourself, as we did in the first example using PHP.
you set up a YAML file first?
Yes, exactly. It's using the OS client config project as well with a cloud.yaml. So you set up all your clouds, and yeah, you have them accessible just by calling them by name, so to say. You define, you get your cloud, so to say, and you're working with that as any Python object, so to say, and do operations on.
So I just want to understand this Shade you are using here. Is it one component that you are using outside the OpenStack and accessing the REST API to do whatever you want to do? Or?
You can say that Shade is a wrapper of the API, so to say, and provide you with functionality inside Python.
But is it Shade included in the OpenStack?
No, it's not, but it's related. So it's the client tool to work with OpenStack Cloud, so to say, to operate the cloud or interact with them. Automation is used everywhere, and it's yeah. If you're doing any kind of DevOps, automation is probably part of that. And whatever tool you use, yeah, you have to do it. And we at City Network use very much Ansible very much. We like that. That suits our needs very well, especially since it's SSH based. So it's very easy to interact with any kind of server. In this example, I will spin up a VM via Ansible, also using the OS client config or the clouds.yaml, so you can set up your clouds, whatever clouds you are using around the world, and choose in which cloud to do your operation, so to say. So we set up a VM here, and we auto assign an IP to it, and then we will SSH into the newly created server in the cloud, and install my favorite package of them all. Very important to have that package. So it's a very good tool for automation, I believe. I don't have that much experience of the other tools, but I like OpenStack very much, especially when you are working with OpenStack, since it's very integrated with the OS client config and those kind of stuff. And Python Shade was initially created out of Ansible from the team in Ansible, developing the stuff like the functionality that is used in Shade as well. Okay, so I think we are waiting for the instance to get spawned up here.
Are you booting from image, or is it?
I'm booting from image, yes. So it's standard Ubuntu image we're booting on. So okay, now it looks like it's created, and we got an IP as well, and we do some installation on the server. So now we are inside the server here and installing the very good package.
But this stuff you can do with Heat, right?
You can do Heat and Ansible, or you can use it as the same, but it's two different things. So yeah,
Nice.
that's a great package. Yeah, but you can orchestrate. You're doing orchestration with Heat inside of OpenStack, so to say, and you can interact between OpenStack and Ansible. And you can fire away your Heat stack with Ansible and tell Heat that when your stack is complete, do this command or call this URL or whatever.
But that requires cloud init in your image, right?
Not to fire away Heat, but to do certain operation. You can cloud init is another thing. It's something that you send into the instance at creation, so to say, and you do stuff.
But isn't it what you have done, that you install the package in the...
No, in this case, let's see if I can go back to that slide. In this case, I don't see it here. If I play, and maybe I can as well pause.
I'm talking about the metadata you pass to your VM to be run when it's coming up.
Yeah, I don't do that in this example. In this example, I just spin it up, and here I tell Ansible to wait for the server I just created until the SSH is available on that server. When it is, I add it to the inventory, but then I SSH into that newly created server and just do apt-get install command to get the package in there. But you can do that with Cloud Init as well. But then it's used, you send that into Nova.
Yeah, and then you need to have contact to your metadata server, right?
Yeah, exactly.
Vegetables.
Yes, yes. Yes, that was all.